Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for reversing bits problem. Let's look at the problem description. We are given a 32 bits unsigned integer. We have to reverse the bits in that number. Let's take a look at the example 1. This is the input number in a binary format. So we have to return the unsigned integer with all the bits reversed. For example, if we see the last 4 bits 1 1 0 0 and the reversed will be 0011. This is a decimal number for the binary string with all the bits reversed in the input number. For the example 2 also, all the ones except the second from the last bit is not set. So after reversed, it is the second bit from the left that is not set. The rest of the bits are set. And then we return the equivalent decimal number. Constraints for this problem is the input number must be a binary string of length 32. And follow-up question is, if this function is called many times, how would you optimize it? Let's look at the approach to solve this problem. First, we initialize the output number with value 0. So all the bits is cleared in that number. And we initialize the mask with the number that has the most significant bit in the 32-bit value is set. Okay. Then we check whether the least significant bit is set in the input number. If that bit is set, then we OR the mask value with the output number so that the most significant bit in the out number will be set. Once that is set, we do right shift the input number 1 bit and also the mask value also, so that the next iteration it points to the next bit that needs to be set depending on the least significant bit. So we repeat this process until the input number value becomes 0. Once it becomes 0, we can break out of the loop. Then the output number will have the integer value that is equivalent to the reversed binary value of the input number. Okay, that's what I have written here. Initialize the output number to 0 and initialize the mask to 31 so that the most significant bit is set. This value is 2 to the power 31. And if the least significant bit is set in the input number, then set the bit corresponding to the mask in output number, and do right shift the input number once and do right shift the mask once, and repeat these 3 steps until the input number becomes 0. Let's look at the flowchart. Input for this procedure is num 32-bit integer, and first we initialize the output number and the mask variables. Output number with the value 0 and the mask will be with the value 2 to the power 31, and then we enter the for loop. This for loop will run until the number becomes 0. Okay, so first we check whether the number is greater than 0. If so, then we enter the loop and check the least significant bit of the current number. If that is set, then we set the corresponding bit to the mask value in the output number. Otherwise, we skip that and we do right shift the bits in the input number as well as the mask once. Okay, and we repeat this process until the num becomes 0. Once that becomes 0, we come out and return the output number. Let's move on to coding. First, I initialize the outnum variable with value 0, and then initialize the mask with the value 2 to the power 31. Then I write the for loop, and this for loop runs as long as the value num is greater than 0. First I check whether the least significant bit is set in the num by ANDing 1 with that value. If it is not equal to 0, then that bit is set. So I OR the mask value with the output now, so that the corresponding bit value in the mask will be set in the output number. Then I do right shift the input number by 1 bit and the mask, and right shift the mask value by 1 bit. Then I finally return the output number. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So the input number is 3 and the expected output is around 3.2 billion. Okay. So the binary representation of the input number is this. Last 2 bits is set to 1. And first we initialize the out num to 0 and the mask value to 2 to the power 31. So out number is 0. This is a decimal value for that 2 to the power 31. And then we enter the for loop. There we check whether the number is greater than 0. In this case it is true. So we enter the body. There we check whether the least significant bit of this input number is set by ANDing 1 with that number. So in this case that bit is set. So this condition will be true. Then we OR the value present in the mask with the output number. So the most significant bit will be set in this number. So that is what we are seeing here. Okay. So once that is done, next we right shift the input number by 1 bit and right shift the mask by 1 bit. So that's why we see this bit is shifted out. So we have only 1. And the mask from the most significant bit value will be shift 1 bit right. So the mask value will be updated. So then we enter the iteration 1. There we check whether the input number is greater than 0. In this case it is. So we enter the body and we check the least significant bit, that is set. Least significant bit is set. So we OR the current value of the mask with the output number. So the corresponding bit will be set in the output number. The second most significant bit is set. Okay. And then we right shift the input number. So the input number will become 0 now. So that's why all the bits are 0. So in the next iteration we check whether the number is greater than 0. In this case it is not. So we break out of the loop. Then finally we return the output number, which is 3.2 billion. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this procedure. So the time complexity is order of 1 because the maximum number of iterations this for loop performs is 32 regardless of the input value. The upper limit is 32. Okay. So for example, if we take the case 1 where the input number is 3. So in this case the 2 least significant bit is set. So this for loop performs 2 iterations. By on the third right shift this number becomes 0. So we perform only 2 iterations in this case. In the case if the input value is equal to 0, then this for loop from 0 iteration. And in the case where the most significant bit of the input number is set. In that case, the for loop performs 32 iterations. That is the maximum. So if the input number is greater than this value, still the number of iterations is only 32. So that's why the time complexity is order of 1. Space complexity is also order of 1 because there are no additional space allocated in this procedure, only few variables are used. So that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.